Right. So I hope you are ready to take more, and you've been able to successfully assimilate everything that I have modestly tried to communicate. Now, realize that I will. I'm seeking to add one after the other, and all the previous properties get used every time I suggest a new property. And I end up using the previous. Therefore, it is important that you take proper notice of everything that I have done so far. If you have not yet been able to do that, then pause, brush through the stuff that I have already covered, so that you can ensconce the ideas that I am going to deliver to you in a short while from now. Right? So, the next in line that I am going to talk of is what's referred to as a cyclic quadrilateral. First of all, just to give you a background, if there is a triangle ABC, that means if there are three non-collinear points, see, the reason I'm talking of a triangle ABC, that will ensure that the 3 points ABC are non-collinear, right? So if there are three non-collinear points ABC, obviously then you can construct a triangle out of them. Then there is a unique circle that passes through A, B and C. That means any set of three non-collinear points would necessarily lie on the same circle. The circle determined by three non-collinear points is unique. And we've referred to this circle as the circumcircle of triangle ABC. And the points ABC lying on the same circle are called concyclic points. ABC are concyclic points. They lie on the same circle. Lie on the same circle. So if there are any three non-collinear points, they ought to be concyclic guaranteed. Okay. Now, if there are 4 points, suppose these are 3 points ABC, and this is the only circle that will contain all these 3 points. If there is a fourth point, say call it P, then realize that A, B, C, P don't lie on the same circle, because there is only one circle that passes through A, B and C, but it doesn't pass through P. So if there are 4 points A, B, C and P, then those 4 points don't have to necessarily lie on the same circle. So even though 3 non-collinear points will be concyclic, the fourth point, if added to 3, may not necessarily lie on the same circle, right? So in this case, A, B, C and P are not concyclic, That means not every set of 4 points have to be concyclic, in contrast to every set of 3 non-collinear points certainly being concyclic, right? So if there is a point P which lies on the same circle as ABC, causing ABCP to be concyclic points. In this case, ABCP are concyclic points. They lie on the same circle. And the quadrilateral ABCP is cyclic. The quadrilateral ABCP is cyclic. Right? We wish to figure out, and not every set of 4 points that constitute a quadrilateral will be a cyclic quadrilateral. See, if the 4 points on a quadrilateral A, B, C and P lie on the same circle, then that quadrilateral is referred to as a cyclic quadrilateral. A cyclic quadrilateral. A cyclic quadrilateral is what it's referred to as, right? So not every quadrilateral will be cyclic. Of the very many quadrilaterals, some would be cyclic. Let's examine a simple property of a cyclic quadrilateral. Let's examine a simple property of a cyclic quadrilateral. A quadrilateral, I repeat, is cyclic if the four vertices of the quadrilateral lie on the same circle. ABCP. This is a cyclic quadrilateral. It's a cyclic quadrilateral. Now, check a few things. I join A and C to create one diagonal. I join B and P to create another diagonal, right? Now, look at this chord BC. Look at this chord BC. This chord BC at P and A subtends the same angle. At P it subtends a certain angle. At A, this chord PC will subtend, BC will subtend the same angle. Why? Because these are angles in the same segment. A chord will subtend equal angles at points in the same segment. Angles in the same segment must be equal. So the angle at A subtended by BC and the angle at P subtended by PC, BC must be the same. That means this angle, if this is referred to as alpha, this will also be alpha. Right? That's as far as the chord BC is concerned. Angles in the same segment. Angles at A and P must be equal. Now, look at the chord PC. Look at the chord PC. At A, PC subtends an angle beta. At B, PC subtends an angle beta at B. Realize that? This PC will subtend an angle beta at A. At B, PC will subtend an angle beta, right? Now, look at AB. Look at AB. As far as AB is concerned, the angle that it subtends at P is this angle, angle APB. Call this angle gamma. Call this angle gamma, right? And AB at C subtends the same angle. So angle ACB must be the same as angle APB. Why? Because P and C are points in the same segment referred to the chord AB. Referred to the chord AB. P and C both lie in the same segment. So angles at P and C must be the same. So if AB subtends an angle gamma at P, see, it subtends an angle gamma at P, then it again subtend an angle gamma at C, right? Good. Now look at the chord AP. Look at the chord AP. The chord AP subtends an angle delta at P. It subtends an angle delta at P. This is the chord AB and it subtends an angle delta at P. Look at the chord AB once again at C. B and C, do you realize, are points in the same segment? As far as the chord AP is concerned, B and C are points in the same segment, and therefore, if this angle is delta, the angle subtended by AP at B, then this angle ought to be delta as well. This angle ought to be delta as well. Which means now, for this quadrilateral, which is cyclic, we must have sum of, in any quadrilateral, be it cyclic or not, sum of all angles of a quadrilateral, irrespective of the nature of the quadrilateral, ought to be 360 degrees. That means alpha plus beta plus gamma plus alpha plus gamma plus delta plus delta plus beta, all of this must add up to 360 degrees. All of this must add up to 360 degrees. Which means, realize that everything is appearing twice here. So what do we get? What do we get from here? alpha plus beta, gamma plus alpha, gamma plus delta, delta plus beta. So twice alpha plus beta plus gamma plus delta. That's 360 degrees, which means alpha plus beta plus gamma plus delta, right? I could write this as alpha plus beta plus gamma plus delta. That's equal to 180 degrees. Good for us. Now this is what we set out to prove. Alpha plus beta is this angle, the angle at A, angle BAP. Alpha plus beta is angle BAP. And gamma plus delta is this angle, angle BCP. Right? Alpha plus beta is BAP, that is this angle. And gamma plus delta is this angle, angle BCP. And they add up to 180 degrees. The property that comes through, therefore, is the following. In a cyclic quadrilateral, opposite angles must add up to 180 degrees. That means supplementary. Opposite angles must be supplementary. The angle at A plus angle at C must be 180 degrees. Similarly, the angle at P plus angle at B must also be 180 degrees, leading us to a property. Just make a formal note of it. Opposite angles of a cyclic quadrilateral must be supplementary. Opposite angles of a cyclic quadrilateral must be supplementary. That's a property that we arrive at. Now, so if there is a quadrilateral and the four vertices of the quadrilateral are known to lie on the same circle, then we can readily say that this angle plus this angle would be 180 degrees. Similarly, this angle plus this angle will also be 180 degrees. However, it remains to be seen whether if this angle plus this angle, they add up to 180 degrees, then should the points ABCP be concyclic or not? That means the converse of the property. That means if a pair of opposite angles are supplementary, is the quadrilateral cyclic? Is the quadrilateral cyclic? That means should the vertices lie on the same circle? Let's examine which is the converse of the property. That means this time I'm just given a quadrilateral and I'm offered this property. The property that the angle at P and the angle at B add up to 180 degrees. I want to examine then if the quadrilateral is cyclic or not. Right? Let's look at that. The converse of this property, say so this was the quadrilateral and we had 3 points A, B and C. Of course, any 3 points will lie on the same circle. Any 3 points will lie on the same circle. Now, whether the fourth point will lie on the same circle or not is only conditional. So, the quadrilateral that we are talking of, ABCP, we have the following. This angle plus this angle is known to be 180 degrees. I want to see if this quadrilateral is cyclic or not. That is whether A, B, C, P are concyclic points or not concyclic points. This is what we want to examine, right? So first of all, forget the point P. If I look at any 3 points A, B and C, is it guaranteed that these points lie on the same circle? Yes, it is guaranteed, because any 3 non-collinear points would be concyclic, will lie on the same circle. Now, I want to check if the point P also lies on the same circle, given that the angle P plus the angle B add up to 180 degrees. Now what we'll do is, let's assume the contrary of what we want to establish. Let's assume that P does not lie on the same circle, despite the fact that angle P plus angle B is 180 degrees. Let's assume that P does not lie on the same circle. That means, let's say P lies outside the circle. Let's assume that P lies outside the circle and that the quadrilateral is not cyclic. Let's assume that the quadrilateral is not cyclic and the point P lies outside the circle. Now, of course, what's given is that the angle at B plus the angle at P, that means this angle plus this angle, is given to be 180 degrees. They are known to be supplementary angles. Now, let me look at this point Q. Now, do you then realize that if ABCP is not cyclic, we are assuming that ABCP is not cyclic, ABCP is not cyclic. Then ABCQ will be cyclic. ABCQ will be cyclic, where Q is this point, right? Obviously, because A, B, C and Q lie on the same circle are concyclic points. So ABCQ then would be cyclic if ABCP is not cyclic. All right. Now, realize that this angle plus this angle is 180 degrees, right? Angle B plus angle P is 180 degrees. Let me call this angle alpha. Again, since ABCQ is a cyclic quadrilateral, the angle at B, which is this angle, plus alpha must be 180 degrees. Right? This plus this are opposite angles of a cyclic quadrilateral, must be supplementary. But what's given is that angle B plus angle P is 180 degrees also. Now, look at these two with love and affection. Do you realize that angle P then must be equal to angle alpha? You should be able to see that. Angle P must be equal to angle alpha. All right. So this leads us to angle P equal to alpha. Angle P equal to alpha. Now, check the authenticity of this argument, not the argument, but the result, which is out of a supposition, an assumption that despite angle P plus angle B adding up to 180 degrees, the point P lies outside the circle that passes through A, B and C. That means we are assuming that ABCP is not cyclic. Now, if angle P is equal to angle alpha, how good does this result look? Hey, this is CPQ. This angle is alpha. Can angle alpha be equal to angle P? Can this angle alpha be equal to angle P? No. Why? Because for this triangle CQP, alpha is an exterior angle and it ought to be greater than any of the two interior opposite angles. So actually, alpha should have been greater than angle at P. But what turns out is that angle at P and the angle alpha are equal. So this is true. This must therefore be untrue. This cannot be true. Why have we arrived at a faulty result? We have arrived at a faulty result because our assumption was faulty. And what was the fundamental assumption? The fundamental assumption was that angle B plus angle P, despite adding up to 180 degrees, do not end up creating a quadrilateral ABCP that is cyclic. We assume that P did not lie on the same circle that passed through A, B and C. Wrong assumption. P not lying on this circle is the faulty assumption. P must therefore lie on the same circle that passes through A, B and C. And if P lies on the same circle that passes through A, B and C, then ABCP must be cyclic, which means given that a pair of opposite angles of a quadrilateral are supplementary, then that quadrilateral ought to be cyclic. This again is important to understand. I must tell you that if you're beginning to understand everything that we are communicating, then you are growing, you're becoming better with things, and you're maturing in the subject of circles, right? Need to add some more fine tuning to your understanding of the properties. Very shortly, you'll see me with some more. Have fun. Until then, bye-bye.